Hello everyone. Today we are going to talk about the WhatsApp system design. So I'm going to quickly first talk about why we are even covering system design, right? So if you guys have ever interviewed in a company, especially at experienced level, say maybe more than 3 years, 5 years, or senior levels, you definitely would have been asked system design questions, okay, or object oriented design questions, right? So these questions are integral part of interviews in especially in product based companies, okay. So that's why we are covering system design, okay. And a lot of times you would be asked questions like design WhatsApp or design Twitter, design Facebook user feeds, design Netflix, YouTube, right, things like that. So today we are going to cover WhatsApp, and in upcoming sessions we'll cover other system design questions as well that are generally asked in design interviews in product based companies, okay. So first thing I'm going to cover is common components that are being used in design of most of the questions. Okay, so first one that I'm going to cover is DNS. So DNS is basically used to resolve the domain names to IP address. So for example, when you type address like say google.com or amazon.com, right? That name has to be resolved to an IP address, right? We generally use name for usability, so that user doesn't have to remember IP address or long names, right? Uh, so that's why we use names, and those names has to be resolved into an IP address, and for that we use DNS servers. So generally there would be a client, DNS client on a system, and then there is a DNS server. So client actually sends a DNS query to the server, and the DNS server resolves that query and then send back the response. Now there could be two type of queries, recursive query or iterative queries, okay. So if you see this diagram, basically if we type example.com for example, a request is being sent to DNS resolver. DNS resolver is nothing but a client on the system on which you have typed that, and that is basically going to send the request to different DNS servers, okay. Now recursive query is basically what will uh, take the name and then make sure it gives you the final response, okay. And iterative query is basically wherein the client would send query, server will send a response back, and that might not be the final response, okay. So in that case client would send again the query and then keep doing that till it get a final response. Now if you look at this example, there is something called top level domain, okay. For example, in this case it is example.com. So this .com, that com is a top level domain. So first we need to have the root servers for that, okay, and then only we can resolve example.com. So after we get a response for com, okay, which will get the list of root servers, then we'll get a authoritative server response for the example.com. Authoritative servers are like which can resolve the name to an IP address authoritatively, which means they have the information about that domain. Okay, so this is how DNS works in brief. Okay, we are not going to cover it in details. We'll reference some videos. We'll give the reference of some videos that you can go through if you want, and you guys are free to ask if you have any questions. Okay. Then the second common component that we come across in pretty much all the system design questions are load balancing. Okay, and now why load balancing is required is these days any system you take, right, be it YouTube, be it google.com, be it microsoft.com, anything pretty much you see on the web, right. uh, there are a lot of servers involved in the backend, right? It is just not one server, okay. So and one server cannot fulfill the need of so many requests, okay. So when your system load increases, right, you cannot have one server serving everything, okay. So for that purpose we use load balancer. So the client would actually send a request to the load balancer, and load balancer is the one which will send that or route that request to one of the servers which are sitting behind the load balancer. So there'll be multiple servers, as you can see from this diagram, which are sitting behind the load balancers, and they are the ones which will actually which will fulfill the request, actual request, and load balancer is the one which will route you to one of these servers. Okay, so load balancer ensures that it balances the load equally or approximate equally, so that one server will not be under so much load that other servers are idle and one server is under load. It will not happen like that. Okay, so that is why we use load balancer. Okay, so the next one is content delivery system. Okay, so uh, let's say you have a website, okay, that has some static content, for example, some JavaScript files, some HTML files, CSS files, things like that. And that website you have hosted in a region, say maybe US East, or some US region. Now the users of this website comes from all over the world. So there are users in Asia, there are users in Europe, and things like that. And then the speed for this website would be slower for these users as compared to the users who are closer to the region in US. Okay, now to uh, mitigate these kind of slowness, right, we use CDN. So CDN is basically a way for you to deliver content efficiently so that the users would get these static contents from the location which is closest to them. Okay, so there is something called edge server, and then there is something called origin in case of CDN. So origin is basically, say, let's say, a storage on which your static content is there. Now when the first time is user is sending a request from a region, it will go to the CDN. CDN will see if it already has the content user is asking for. If not, it will go to the origin server, get the content, cache the content, and then serve the user. Now second time when same user or any user from that region is actually going to the website, will go to the CDN. Since CDN would already have the content cached, it doesn't need to send to the origin server. Okay, so it will get the response much faster. And then there is something called like edge servers. So edge servers are like different servers being located in a region. So there could be multiple edge servers in different regions, and edge servers share content. So for example, if first time when the user goes to a server, CDN server, it caches the content, it will share that content within other edge servers as well, so that next time if user is being routed through other CDN, it doesn't need to even go to the origin server. Okay, so they are connected to the closest edge servers. So that is what we use the CDN. And CDN is not just for the static content, you can even have dynamic content served through CDN. Okay. Okay, next one is API gateway, or some people call API management as well. So basically, we generally API gateway to take all the API calls from different clients and then route it to different microservices at the backend side. Okay, so basically the API gateway uh, detects what is the best path that it can use to route the request. It can also do translation between different web protocols. Okay, or even it can detect the request, do some modifications to the request, and then send the request to the backend service, get the response back, modify the response, get the response back to the user. It can also perform tasks like authentication and authorization, so that services doesn't need to bother about that. They can just focus on business logic. Okay, so API gateway can do all that, and it is like the a point of contact for the clients. Okay, or anybody who's calling the APIs. Right, so backend services are not exposed to the user publicly. It is only the API gateway through which they can contact the backend servers. So even from security perspective, it's like pretty useful, right? You are not exposing your services to the public world, right? It is only the API gateway through which requests can come in. So you can even do things like blocking requests from certain set of IPs, or things like that. You would need to make use of some more products along with the API gateway to do all this, but it's doable. Okay. Okay, so next one is Elasticsearch. Okay, now Elasticsearch is basically a search engine which is based on Lucene library. So generally in a modern products, you would have a need of searching through certain things. Like for example, if I talk about Amazon.com, you would be searching for different products, right? Or maybe different sellers, things like that, right? So generally we use a product something similar to Elasticsearch. It could be Azure Search, these kind of products, and they basically are being made specifically for search. And you can do a full text search. Okay, and they can search through schema free JSON documents. So it is basically they are being optimized for search, so you will get a much faster response as compared to other products if you search. All right, so that is why we use the Elasticsearch for. Now there is databases. Okay, pretty much every product would be using some kind of a data store, right? And most of the times it would be some kind of a database. So generally we have two kind of databases. One is relational, one is non-relational. Okay, these days called NoSQL, stands for not only SQL. So relational database we generally use wherein we have some kind of a well-defined relationship between different tables. Okay, and so you would have a defined schema for a relational based database. So you would be having a schema, a defined schema, and then you would be storing data, and you would be using structured query like SQL to query the data from these tables. Okay, now then there is NoSQL, right, which are these days it's like pretty much everybody is going towards NoSQL, right? Now generally you use NoSQL to store data which just doesn't have a fixed schema. Okay, things like, for example, you have different devices in the field and data is coming through IoT from those devices, and the data won't be fixed. So for example, some devices will be sending data of, say, maybe just device ID and some metadata information. Some devices might include, say, latitude, longitude information, some kind of a distance, something like that, right? So it would differ depending upon the device type, probably, right? So the schema would be different for each message or each type of device messages, right? So in that case, it's an unstructured data, right? So NoSQL is very suitable kind of database for these kind of data wherein you don't have a schema. It's an unstructured data, JSON kind of data. So you use NoSQL to store these kind of data. Okay, then there is a caching. Okay, so caching is kind of a layer wherein if you want to speed up some things. For example, I'll give you a very simple example of let's say from your web application calls an API. That API has to call a database to fulfill that request. Okay, now if the request is coming for similar kind of a data, right, wherein for every time that API is calling the same set of, or sending the same set of query to database, unnecessarily you are running so many queries on database, and generally queries against database take so much IO and CPU, so those would be slower. Okay, instead of sending all the queries to database, what we do is have a caching layer in between the API and database, and send the request to the caching layer first. If that already has the data, it will send the response back. If not, it'll get the go to the database, get the data from the database, cache the data, and then send the response back. Okay, so this way, if you have similar kind of queries or similar kind of keys that you are querying for, things like that, those will be much faster because those will already be in cache, and cache is in memory data. Okay, so it'll be much faster than querying against the DB. Okay, and generally there will be a TTL, time to live, associated with the cache. So basically the data in the cache expire as per the TTL. It will not be generally persistent for infinite time. All right, now next is microservices. This is not exactly a component but kind of a design pattern or a software development technique wherein you would use a variant of service oriented architecture, and you defined a collection of loosely coupled service. Okay, so you basically design services which are independent, which are isolated, which can be developed in isolation. Okay, and which can be deployed without being relied on other services. So a microservices is one which does a particular functionality and does it well. Okay, so these are loosely coupled services, isolated services, which does one task well. So to basically, if I talk about, say, maybe an e-commerce website, something like Amazon.com, you would have different microservices. Say one microservice is maybe for let's say handling carts, right? One service for handling user profile, one service to just show you the products, right? Things like that. So there'll be so many microservices if I talk about a particular product. Okay, next comes messaging. Now so we use messaging when anytime, say, a microservice needs to communicate with each other. Okay, uh, messaging is generally used for anything wherein you want asynchronous processing. Okay, messaging follows the publisher subscriber pattern. So so basically, there would be one publisher which is publishing the messages to, say, a queue. Okay, for example, and then there would be a subscriber which is getting that message and does some processing with it. All right, So messaging we use in at different places, right? So we will also see how we are using messaging when we talk about the WhatsApp design. All right. So there are different products you can use for messaging. For example, the SQS SNSs in AWS or Azure Service Bus queues or topics. Okay. So basically, here if I take an example, when a microservice need to communicate with one another for to complete a particular functionality. Okay, it can send a message to a particular queue, and then other microservice can read that message and then does some action, maybe send a response back through the queue to the other service. Okay, things like that. All right. Okay, so we have finished the common components, and here these are the basic features for WhatsApp that we would be covering. Okay, in the next session. Yeah, thank you.